All right, so welcome to Code Camp, you guys. Thanks for coming out. I'm really excited. I hope you guys are too. Why don't you guys, can everyone just say their name real quick for the whole group, because we're going to be here and hanging out and stuff, so probably good. Andrew. All right, nice. So the way this is going to work is it's 2 nights a week for 8 weeks here. So Monday nights right now 7 to 8, and Wednesdays 7 to 8:30. Monday nights are going to be kind of like a lesson, and then Wednesdays are going to be like a lab where you guys are doing a project and stuff, and I'll be here to help you. So it should be pretty fun and hopefully stress-free. And if you miss a class or whatever, it's fine. I'm going to put up the recordings online. You can just watch them. Or if you can't make a lab, the projects will be released so you can do it at home. And yeah, but it'll be good to come out, and let's get going. All right, so before we get into the specifics, I want to kind of give you guys some motivation, although you guys are already here, so obviously I'm kind of preaching to the choir, but why? Why learn to program? Why learn to code? Why do it at all? Well, one reason is I'm sure you guys have had ideas. You've had app ideas, maybe you've had business ideas, maybe you want to build a website, maybe you want to just make some product work that you think would be cool to have. And right now maybe you have a barrier that you can't get your ideas realized. You can't make the app, you can't make the website, you can't make your things a real product. Well, if you learn to program, this will kind of take away that technological barrier, and then you can go from there. Another reason is what programming really is learning a new way of thinking. It's being able to problem solve. It's being able to organize your thoughts so that you can efficiently get something done. And this actually comes up a lot in life when it's just not on the computer. Maybe you have some problems you've run into that would be easily solved with a similar way of thinking. Another one is what everyone likes to hear is that basically there's an abundance of jobs, and there's an abundance of high-paying jobs. So if you can learn how to program and you can learn how to code and you like it, then there's a lot of guys that will pay you a lot of money to do so. These are some of them, and there's thousands more, and it's definitely, that's a really nice perk. And another reason, which is one of the things that got me going on it, is that it opens up a lot of entrepreneurial doors. It really allows you to create your ideas, get them out there, get them out to the masses cheaply and quickly, and change the world, really. Like, these are all apps that maybe you recognize, and they've had a really big impact on the world, and it's been started by maybe 1 to 4 people, and they've really made it happen, which is pretty cool. There's not really much else like that, which is awesome. So those are some of the reasons to get you going, even though, like I said, you're already here. So, but all right, let's get into it. Let's get going. So what is a program? What is a program? Microsoft Word, Google Chrome. These are examples, right? But what is a program? What does it really do? Well, a program is a list of instructions. Nice. So it doesn't really have to be that complicated. It's just a list of instructions to be executed in an order for a given purpose, to accomplish a goal. And so here's a kind of an example about how you would tell someone how to brush their teeth. This is a program for brushing your teeth. Obviously, it's a little silly, and it's not necessarily getting anything important done, but if you were a human, who spoke English, who didn't know how to brush your teeth, and you read this, maybe by the end of it, you'd be able to figure it out. So that's pretty cool. It's not trivial. All right, so that's what a program is. Now, what's a computer program? Well, it's pretty similar. It's got one extra stipulation, and that is a list of instructions that a computer can understand. So, what do I mean by this? Well, here's an example right here. It might be kind of hard to see with the lights, but can you guys read this? So this is a sample Java program. This is like a real deal. This will run. It's not going to do anything that important, right? But okay. So let's go through it real quick. Does anyone have an idea what this does? No ideas? Well, what it does is displays the name of the best rapper ever, right? And that's pretty easy because everyone knows it's Biggie Smalls. But this is really simple. But this is an idea. And so you're probably thinking, okay, a computer, how can a computer ever understand this? Computer can't understand English, right? This looks kind of like English. There's some English words here. I don't know what this is necessarily, or this stuff, but how could a computer ever understand that? Well, the short answer is it really can't. A computer can only understand one thing, and that's machine language. This is kind of the classic binary zeros and ones that you probably maybe associate with computer programming. I'm not sure. Maybe that's what you thought you'd be writing here. Well, what these binaries are is just kind of like a representation of the two different voltages that a digital computer can understand. And this is like the first abstraction that made computing possible. This is really important. This is really awesome. This is what made it happen. But there's one downfall. It's pretty confusing, right? Do you guys can you understand what this means? It's pretty, I can't really understand what this means. It's hard. It's not intuitive for humans. It doesn't really work.
Is it okay to turn the lights off?
Yeah, sure. Go ahead. Yeah, I'll get Maddie to do it. Maddie, can you turn the lights off? All right. Nice. Yeah, that's better, right? Okay. So, like I said, a computer can only understand one thing. And that's these binaries. But it's not great because we can't really understand them that well because they're really confusing. So, we decided to come up with assembly language. Okay? This is a little better. This is a step above machine language. They decided, okay, you know, we're going to get rid of these zeros and ones, and we're going to create these commands that represent what the zeros and ones are doing. So maybe you have an add right here. So you don't really know what these are yet, right? This is still a little confusing. But you say, okay, maybe some stuff's getting added together, and it's sure a hell of a lot better than this. But this is still a little clumsy. I mean, it's hard to get anywhere just doing simple commands: add, store, load to memory, take away from memory. It's kind of, it's really clumsy. So, decided to go a step further and create high-level languages. These are your Javas, your C++s, your Rubys, your Pythons. Everything that you probably have heard of as a computer language is considered to be a high-level language. And what this means is each instruction that a high-level language completes is made up of a bunch of small little lower level instructions, and it makes things go a lot quicker. Also, if you can read this is an example of a Java line. It's pretty easy to understand compared to this, right? I mean, maybe you don't know exactly what's going on, but you can see there's something called an hypotenuse here. There's some square rooting going on. It's pretty similar to English and math. It's not directly either one of those things, but you know, it's not exactly very confusing, and finally now we can kind of start to understand what's going on, which is really nice. This is really good. But now you're probably thinking, okay, well, you said that the computer can only understand this, and now you're saying that we can write this. Where's the missing link there? Where's the connection? Oh yeah, okay. There's a bit of a tangent to go on here, and that is that this is an increasing level of abstraction as you go down here. Now, I wanted to bring this up because the concept of an abstraction comes up a lot in computer programming, computer science, and it's not necessarily very obvious. It's pretty confusing, actually. I really struggled with it when I started. And so I'm going to try to do my best to explain what an abstraction really is. Let's say I say the word cat, C-A-T, right? You guys can all, as English speakers, understand what the word cat means. You can visualize what a cat is. You can understand some of a cat's traits, right? There doesn't have to be a cat anywhere in the room for me to point at, or a cat outside anywhere for you guys to be able to understand that, right? Well, that's basically an abstraction. The word cat is an abstraction for the physical being of a cat. And if you extend that, the whole English language is really an abstraction for whatever it represents. Any language is an abstraction. So that's pretty useful when you really think about it, because now I'm able to communicate all these ideas to you guys without having to point at a bunch of different stuff and make noises that, well, I guess I am making noises and pointing at stuff, but maybe it's a little easier than it could be. So that's an example of like a simple abstraction, which is kind of what's going on here with these assembly languages. We're taking this and we're calling it cat. We're calling it add, right? Now, let me give you an example of a little bit more of a higher abstraction. Let's say I say the word thought. Okay? The word thought, T-H-O-U-G-H-T. Now, this is interesting. This is a little bit different than the cat example, right? Because I personally, and I'm guessing most people, don't actually know exactly what a thought is. I know it's something that goes on in the brain that involves like electrical impulses and neurons and stuff. I don't really know the details, and I'm sure most people don't really know the details of what a thought actually is. But you are able to understand what a thought means. A thought is a formation of an idea. A thought is what your brain does, right? Your brain thinks. So this is an example of a higher abstraction. I can say a word thought, and we all kind of know what thought means. We know the gist of it. We know the big picture. But we don't actually know exactly what a thought is. But it doesn't really slow us down, right? We're still able to use the word thought and say think, and everyone's not confused, which is really nice. And that's kind of more what these high-level languages are doing. They're saying, okay, we have the ability to do these things, and we don't have to worry at all about what goes on beneath them, because we know that they're going to work. It's going to be fine. Yeah?
I know this is sort of irrelevant, but how did they make the systems like Java and C++?
Yeah, okay, that's a really good question, and that actually leads into the exact next slide. So it's not magic, right? I said machines only understand machine language, and that is true. They can't just magically learn Java or whatever. So what we have to do, well, we don't have to do it, someone already did them, which is really nice, is create these things called compilers, okay? And what a compiler is a program which translates your code in Java or C++ or whatever you want into machine code so it can be run, and so it can be an actual program that's useful, which is really nice. And in doing so, it defines the language. It says what rules you can and cannot do. It says, okay, you have to put a semicolon here, or you have to, make sure your spaces are like this. Now, these are really impressive pieces of software, and if you continue with computer programming CS, you will probably eventually write one. And they do a lot of things that you probably won't appreciate as like a beginning programmer, but they are really, really cool. But for now, all you have to know is that you write your Java program in Java, and then you hand it off to the compiler, which is Java-C for Java, and then it turns it into machine code, which is then run. So you don't really have to worry too much about what goes on in there, but just know that that's what's happening. In fact, a lot of times they don't even really tell you this when you're first learning, but I think it's really nice to know the big picture, so you're not just kind of like punching stuff into this black box. You gotta kind of like deconstruct the black box. So that's the idea. Now, let's get into the details. Let's make it happen. Now we kind of understand what programming is all about, or I hope at least, or we got an idea of it, and we understand how we can get our programs into the machine and make them run. Not completely understand, but you get the idea, right? All right. So, our first two tools as a programmer are going to be the following things: variables and methods. All right? So what variables are is they're really similar to their algebraic counterparts. Variables in algebra, right? You guys have all dealt with these before. It's your x's in algebra, your y's, your equations. They're things that represent value. They don't necessarily have an exact value, but they will have a value at some point, right? Just like in algebra. And in programming in Java, every variable has a type, a name, and a value. The type tells you what type of thing the variable is going to hold. And I'll give you some examples of this later. The name is how you reference the variable, how you use it in code. And the value is what exactly the variable holds at any given time. Okay, so that's variables. This is like an introduction. We're going to go through the slides shortly here. In methods, this is a little different. Methods are the muscle of your program. They are blocks of code that you can call upon to reproduce. You can create a method and then use it wherever you want. They're really, really nice, and they do a lot of really nice things for you, and you'll see how they work very shortly. But methods have a return value and parameters. This is like an input, and this is like an output. Okay. So, I also need to say one more thing before we keep going. It's inevitable that you guys are going to be confused here. It's just, this is a bunch of new stuff all at once, right? You can't possibly understand exactly what I'm talking about here or exactly what I'm talking about here or exactly what I'm talking about with anything, because this is all new to you probably, right? So don't stress about that at all. It's totally fine. That's how computer science works. A lot of it is you being confused and then overcoming your confusion by not getting flustered and just thinking through it. So don't stress about this. I'm going to be saying a bunch of stuff. You're going to say, oh, okay, that doesn't really make sense yet. I don't really know what you're talking about. But it's totally fine. We'll get into the lab on Wednesday, and we'll go through some stuff, and it'll start to make sense. And then next week we'll go through some more stuff, and you're going to be confused for a little while, but then eventually it's going to kind of click, and you're going to say, okay, I can kind of see what's going on here, and I can understand how to make this stuff change and how to make it work the way I want to. So don't get intimidated at all. It's totally natural. This is kind of a complicated thing, but it's not so complicated that you can't get it. Everyone can understand. You just have to keep at it and be willing to have an open mind and not get confused. All right. So that was my little spiel on not getting intimidated. I hope you aren't intimidated. But okay, let's get into variables more in depth. So, like I said, every variable has a type. Well, what types can we have? Oh. Well, here are 5. And they're all pretty straightforward, but the names are probably going to be new to you. Let's just go through them. So we got ints, which is an easy one because it's just short for integer, right? So this is anything. This is 1, 20, negative 1 million, 0. This is any integer that you can think of, just like in math. So that's our first type. Our second type is double. It's kind of a weird name. It stands for double floating point, but you don't have to be concerned with that. Just have to know the word double. And this type is any real number. So just like math again, it's 2.76 whatever, 1.0, negative 1,000. It's any real number, decimals included. Okay. You guys with me so far? Yeah, Zach. Okay. Well, every integer is a double, but every double is not an integer. But it's not necessary. It acts a little bit differently than that, but you can think of it like that for now. Double is basically more precise, and you're probably thinking like, why do we even have integers if we have doubles? Well, it comes down to like kind of some memory. It gets a little more complicated, but basically it's more simple to use integers when you can. If you know something's never going to need to be a decimal point or anything, then just use an int. But it's not too big of a deal. Just keep going, you'll understand.
What's a double that's not an integer?
A double that's okay. 1.7 or anything with a decimal. So yeah, anything with a decimal is not an integer.
It's just like a straight up number.
Yeah. No decimals at all. No fractions or whatever. A whole. No, is it a whole number?
An integer is a whole number?
Is that what they say? I can't even remember exactly what it is in math. Is it a whole number? Yeah. Okay. Yeah. Yep. Okay. All right. Yeah. So we cleared that up. So now our third one's going to be char, and this is short for character. I guess you could say char too, but it's a little confusing. So this is any single character. This is like B or Z or any letter or an ampersand or 1. It's any character. And again, you might be saying, okay, if you can have 1 as a character, then what's the difference between 1 and 1 as an int? Well, 1 as a character doesn't really hold like a numerical value. It's simply a character. It's interpreted as something different. Again, this is going to be confusing right now, but it'll make sense soon enough. Yeah. Well, it's kind of like, well, these are all actually just variable types, right? But this is what, like the type that it'll hold. You'll see. We'll push forward here, and it'll become more clear. And then our fourth type is going to be string. Now, a string is a series of characters. It's a bunch of chars. And this would be like a word, like hello or pancake, or it's a string of random stuff that you can't even understand, that maybe sometimes you'd want to use. So this is actually a really, really useful one, because it kind of bundles a lot of stuff into one, right? You can have like a whole paragraph as a string, or a whole book as a string, or just one letter, or whatever you want, right? It catches a lot of things. And then our fifth and final variable type for now is going to be Boolean. And this is probably new to you. This is something that's pretty specific to computer science. This is a true or a false. Okay? It can only be two different values, true or false. And and they're really pretty important, and they're really simple too, which is nice. So these 5 types that I just described to you guys are called the primitive data types. This is what you get for free, basically, in Java. This is always going to be there no matter what. You can always use these types when you're writing in Java, which is cool. And the final type we're about to talk about is really what is really, really important. And we're not going to talk about it too much today. This is for next time and the time afterwards. This is called an object. Okay? And what object is it's really an umbrella which defines all other types that aren't these types. Okay? And objects are written by you. You create objects. You create whatever type you want. And again, this is going to be confusing right now, but it's going to be more clear next time and in weeks to come. And objects are so important that Java is actually considered to be an object-oriented programming language. It centers itself around creating objects. So that is something we're not going to touch now, but just know it's a thing. Know that it's not just these 5 types right here. It's another type, which is actually a bunch of types. But again, don't worry about it right now. Okay, so now we got our types. How are we going to use this to create a variable? How are we going to create our first variable? Well, to create a variable, you have to declare a variable. And how do you declare a variable? Well, you declare it like this. Okay? This is your first piece of Java syntax right here. This is how it works. Okay? You put your type, in this case string, you put a space, and then you put your variable name. And you finish it off with a semicolon. All lines of code in Java end in semicolons. This is just like how the language works.
Does the semicolon have a space in between it, or is that just...
It actually doesn't matter, but you typically wouldn't put a space there. That's another thing. White space in Java, it doesn't matter if this is 1 space or 3 spaces, if there's a space here, if there's a bunch of spaces in the beginning, it doesn't really matter. But in order to make your code really readable, you should probably just kind of be reasonable with your spaces. And so here's your variable name, and here's your type. That's a variable declaration. Now you have a variable called first name. Right? Pretty nice. Pretty simple. And you can, this is what's really nice, you can name your variable anything you want when you create it. Anything you want. This could be anything you want. The only problem is you're not allowed to put spaces in the middle of your variables. Okay? And yeah. But you don't want to just name it something crazy. Like if you want to kind of follow some conventions. The first of them being that it should represent what the variable is going to hold, right? So if you've got a variable called first name, it's probably going to hold someone's first name, right? You wouldn't want to call a variable that was going to hold first names like, you know, hot dog or coffee or something. That would just get really confusing. So that's a good convention to follow. Another one is that you want to make your variables have a lowercase first letter. And in order to help you see multiple words, you can capitalize the first letter of a following word, just like kind of how this works right here. That's called camel casing. But that's just like a stylistic thing to make your code more readable. But it doesn't actually matter in terms of how your program performs. But, so this is it. This is your first piece of code right here. It's pretty easy to understand, right? Any questions so far? Yeah. Right, yeah, this is just an example. That's a type. So any types that we just described, you could use here. So you could use, you know, int, and this could be, I don't know, number of cars or something like that. So yeah, but we'll go through that as we go here. So this is pretty good, right? But the problem there is first name, it doesn't have a value yet, right? We said every variable has a type, a name, and a value. Well, this one's got a type and a name, but no value. It's just been declared. It's just been created. It doesn't mean anything yet. So, how we give our variables value is by defining them. So how you do that is like this. Okay? It's pretty simple again, right? All right, we got to go through it first, though. So this is our variable that we just declared, first name. Now, in order to give it a value, we have to put an equal sign and then a value here. And strings and chars are always encompassed by parentheses, okay? This is just like another rule of Java. And I realize this is a lot to keep track of, but don't really stress about the details. You're going to forget them, and then we'll refer back to these slides, or you can just ask me and we'll figure it out. Is that, what did I say, parentheses? Yeah, quotes, I mean. Yeah, sorry, quotes. So strings or chars encompassed by quotes. Oh yeah, just like it says right there. And again, we got our semicolon to end the line off. And so the confusing thing about definitions is this. This equal sign does not mean equal, right, in Java, which is really kind of funky. Like, why do they do that? I don't really know exactly. What an equal sign means is it assigns value, okay? This is just something that you've got to just force yourself to learn, because it is a little confusing when you're writing code and you want to read it as equals. What you really have to say is gets, okay? So you can say first name gets Bill instead of first name equals Bill. It just makes a little more sense to yourself. It's just something you have to get over. You guys kind of follow so far? Or? So this is how you assign a variable a value. Now we've got first name, we declared it, it's ready to use, and now it's got a value, Bill. Perfect. All right, so let's push forward. Oh. Okay. So declaring your variable in a line and then defining your variable in another line is totally fine. No one's going to get mad at you. Java says it's totally fine. I'm not going to yell at you. No one's going to yell at you. But if you want to do it a little bit quicker, you can put the two into one line. So if you look at it like this is your declaration here. String space first name. So you've declared your variable. You've declared your variable called first name of type string. And then your definition is over here. You've given your variable name first name the value Bill. And of course, since it's a string, we've got the quotation marks. Okay? Yep. It doesn't, but it makes it a little bit more readable if you put it there, so it's not like all scrunched up into one really dense line, you know. Usually, like, it's nice to put a space between things. But for instance, if you put a space here between the quotation mark and Bill, then your string is going to have a space there. The value of your string will be space Bill, you know. So that's where it starts to matter. But you'll see as we go along again. Okay, yeah, that sums up what I just said. All right, so this is going to be kind of the overview for variables. If you can understand this slide, then you're well on your way to understanding how variables work. So let's just go through it real quick. What's this line doing right here? This first line, string space first name.
Just like making a name for it?
Yeah, it's just declaring this new variable, which we've already done 3 times over the last couple of slides, but it's just declaring this variable first name of type string, right? Yeah. Okay, so what's the second line doing? Yep, and it's got the same type, right? String. So this is a totally new variable. We've declared first name, and now we've declared last name. We've got both of them. They're totally fine. You can just use them. And what's this line doing?
Giving it a value for the first name.
Right, it's defining first name. What's the value of first name now? Bill. And similarly, this one right here is giving the last name a value, Clinton. Okay, so this is a little new right here, right? String, full name, gets. What's going on over here? Any guesses? It's not really fair because this is new syntax, but what this plus sign, yeah, you want to guess? You take a guess?
Just like, because it just knows 2 different things, so to get the full name, so you can type in like, what's the full name?
Yeah.
It's having it so that it's in order, right?
Yeah,
Otherwise it wouldn't know which order to go.
basically, what it's doing, so this is just a new variable here, right? Full name declared, just like these last 2. And now it needs to be given a value, right? So we've got this gets sign, this equal sign, which we're going to read as gets. So full name gets first name plus, what's this? This is just a space, right? Which is a little confusing. Yeah, see, this is like another string. And then this is plus last name. So what these are called in computer science with strings is concatenation. It's basically smashing the strings together. So you've got your first name string you've got your space, and you've got your last name string, and it smashes them all together. So what full name is Bill space Clinton, right? It's one string, that's Bill space Clinton. Now again, I'm going to keep saying it, but you don't have to stress. It's just a little confusing, and you'll see later in lab. And then this is our first non-string variable, right? So what's going on here? Yeah, so we've created a whole new variable right here, right? Int is the type, pres years is the name, and the value is 8, right? So this is kind of an overview of strings, and this is the general idea. You've got your declarations, you've got your definitions, and you've got your declarations and your definitions in one line if you want. But really all you need to know is that a variable has a type, and a value, and a name. The type and the name, don't change. The pres years, this variable pres years is always going to be of type int, and it's always going to have the name pres years. That's how you refer to it. But this variable 8 can change. You can change it whenever you want. You can change it lower down in the code. Whenever you refer to it again, you could define it again. You could say pres years equals 12 if you got another term, which is obviously not allowed. Okay, I see what you're saying. Well, it technically doesn't because, like as we said before, a programmer is a list of instructions, right? So all that's going to happen is it's just going to be executed in a list. And so when this is first defined, it's going to be 8. So it's 8 then. And then later down when you change it to 12, it'll be 12. It doesn't, this has already happened in the program, so it's fine. It doesn't even matter anymore. But you can change it later on, basically, is the idea. So that's variables. And variables are really cool and really important. And if you can understand variables and how they work and how to use them, then you're well on your way to getting going as a serious programmer. But with that said, you're not really going to get anywhere just declaring and defining variables, since you've probably already seen. You're probably thinking, like, what's even going on here? You're just making a bunch of variables and nothing's happening. Well, that's exactly right. Nothing is happening. So what we need to do is talk about methods. Methods are what we're going to use to manipulate our variables and use them the way we want to use them and use them what we need to use them for. And you'll see what I'm talking about. Okay. So what a method is a series of instructions with a name, okay? So it's like maybe you have a method called ride no hands, all right? And maybe that tells you how to ride your bike with no hands, right? And what it really is, a method is an abstraction, like we talked about earlier, for an ability or a function. So us as humans all have a bunch of methods, right? We know how to sleep, we know how to eat, we know how to walk, we probably know how to run, we might know how to drive a car. We know all these things. These are all our methods, right? So you can think of a method as what an abstraction for an ability. The ability to run, the ability to sleep, the ability to eat, the ability to talk. So that's the idea with a method. And then, this is what might happen if you ride your bike with no hands. Okay, so we got to talk about the syntax of methods. So just like variables, methods have to be declared, right? Remember when we were declaring variables, we had to tell Java what we were going to call our variable, or a variable, and what type it was going to be. Well, you got to do a really similar thing with methods. And this is how it looks. Okay? And unfortunately, it's a little bit more confusing, right? It's not quite as simple as what we were just talking about. But it's fine. We're just going to go step by step here, and we'll figure it out. So the first part is this modifier right here, the first thing. And this is either public, private, or protected. But for now, every single method you write is going to have a public modifier, okay? So don't even worry about it. As soon as you're writing a method, just put down public. All like this, lowercase public, and then what we're going to have is a space. Oh. And the next thing is the return type. So the return type is what your function or your method is going to output, right? It's going to be the output of your method. And this is the type of variable that your method is going to output. So the variables that we were just talking about all had types, right? Well, this function, or this method, is going to return or output a variable of type double. Okay? So it'll all become clear when we define it, or it'll become more clear. Now, every method also has a name, just like a variable. And this method's name is average. And just like variables, you probably want to follow kind of a similar convention. You want to name your method what it's going to do. So you don't want to name a method that's going to average a couple numbers add, right? That would be really confusing. If your method's going to average something, maybe call it average. And here as well, you're probably going to want to start it off with a lowercase letter. That's just a kind of a coding convention that's been accepted for whatever reason, but it makes it more readable. And then these two things over here are our parameters. Okay? These are the input to our method. These are what are going to go into the method, and they're going to use to produce an output. So in this case, we've got two doubles, right? So this looks pretty similar to what we were just talking about. This is basically a variable declaration. If you can see, it's got a type, and then a name, and then another type, and another name, separated by a comma. This is the input to our function, or our method. And the final part of syntax is that you need to encompass your method with these curly braces. That's just the way Java likes it. So, this is a method declaration. You guys got any questions? You're probably thinking I'm never going to be able to remember how to do that, or what order to put things in, but you will slowly but surely be able to figure it out. And I'll be here to help, which is good. So, again, just like variables, our methods need to be defined. Now, with variables, the definition was assigning the value to the variable, right? Well, with methods, the definition is telling Java what your method is going to actually accomplish, what it's going to do. And your definition has to follow the declaration that we just made. It has to have a return type of double, and it has to use the inputs that it was assigned. Okay, so here's the definition fleshed out. So here it is right here. So you can see it, our declaration is up here, and our definition is right here. Now, let's just go through it line by line. Can you guys see what's going on here?
Yep.
What's going on? Right, and what are we putting it into? So the sum is what? A new variable, right? And we just created it right here, right? You can see because we've declared it. It's a new variable with a name sum and of a type double. And what's this again? Gets. So this variable sum gets these two numbers, which are the input, right? You can see where these are coming from. Do you see? And it's, of course, finished off with a semicolon. So that's the first line. Now we've got a variable sum, which has the value of the two inputs, num1, num2, added together. Right? Not too hard. Okay, this next line, what's going on? Can you guys see? Right, and where's it going? So what's average? New variable, right? And what type is average? Double. So there you go. Not too bad, right? And then this line is kind of new, right? We haven't seen this before. Well, this defined our return type, right? We said we were going to return a double from this function. This method or function, you can kind of say them interchangeably, but you're actually supposed to say method in Java. is going to return a variable of type double. Well, here we go. It's returning a variable of type double called average, which we just declared and defined up here, right? And so what return means is it's going to output that variable to Java, basically. And that probably sounds like a bunch of gibberish, but you'll see shortly. As we get going here, things will you'll start to amass more knowledge, and you'll kind of see what's going on. Yeah?
So, I forget what the name is, but at the top it says public double average. What is that average called again?
That's the name of the method.
Okay, so the name of the method. Do you always have to have the name of, like, whatever's returning, that's the same name as the name of the method?
Oh, okay. Yeah. That's actually just a total coincidence. This can be anything you want. This, it could say av or anything else. It doesn't matter. That's a really good question, though. That's just a coincidence here. And Joe, you have a question? Oh, okay. That's another really good question. Yeah, it is because it's a double, and it's actually allowed to say just 2, but it's better practice to use a double when you're dividing another double. You should just tend to try to do that. It's not actually necessary, but it's better practice, I guess. Any other questions? Yeah.
Do we have to tab them?
That's another really good question, and actually the answer is no. You don't have to. It makes it more readable, and actually the program that we're going to be writing in is called Eclipse, and it's going to do all this for you. It's really nice. So your formatting and stuff will kind of be taken care of for you, but it's actually not important. There are languages like Python that require you to do tabs particularly, and make sure that all your white space, like your spaces and stuff, are really exactly how you need them to be. But Java's not like that at all. This doesn't matter. It just makes it really a lot more readable. So yeah, that's how you define your method. This is going to be a method which takes in 2 numbers and averages them. And so now you've taken these 2 inputs and made the output the average, right? So that's pretty cool. It's really cool, actually. It's probably cooler than you think at this point, because what this means is now at any point in your code, after you've written this method, you can average 2 numbers. You don't have to write all of this stuff. You don't have to do it every single time. You can just say average the 2 numbers, right? That's really nice. And when you start writing methods that are more complicated than averaging, it's going to be a big help. And you'll see how it works as we go. Okay, and also, let's do a quick side note on comments. So what comments are is these 2 things. And you've probably seen these in the slide so far. And comments are totally ignored by the compiler. They don't affect your program at all as it runs. So what they are used for is you, as the programmer, use comments to remind yourself what you're trying to do in the code, right? Because even on code that you've written yourself, it gets pretty confusing sometimes as to what you were trying to do exactly. So what you can do is put a comment above a line of code and say, okay, this line of code is going to add the 2 inputs together. Or this line of code is going to divide and create the average, right? And that was just kind of helpful reminders to yourself or anyone else who works in your code in the future once you start teaming up on projects to remind you what your code is doing and how you can maybe fix it if you have a problem. So basically, use comments, use them a bunch. If you pursue computer science and take college classes or whatever, they're going to grade you on how well you comment, which is kind of interesting because it's not actually how good your program is, but it really helps you as a programmer, and it's really good practice. So that's my spiel on comments. Okay, back to methods. So we've got the idea down. Yeah. Yeah.
So the forward slash.
Oh yeah, sorry.
What's the difference between the top?
Right. I should have explained the syntax here. Okay. Wait. Okay. So this first one is a 1-line comment. So if you put these 2 slashes in back to back, then that initiates a comment. So anything after 2 slashes in Java is a comment, and it will no longer matter in your code. And you'll see in the program that we used.
Put something at the end of it too?
What's what? No, you don't have to. You don't actually have to. It's just 2 slashes and then a comment. But if you hit enter, then you've got a new line and it'll no longer be a comment. So what you want to do for a really long comment, like maybe a paragraph that you're writing to yourself, is use this which is a slash and an asterisk. So if you do this, then it basically starts, everything below that will be a comment until it hits this, which is an asterisk and then a slash.
The top one, what does it have to hit?
It just, as soon as you hit enter at the end of this line, it stops being a comment. It'll just go back to your code. And again, this is made easier in Eclipse. It'll color your comments a different color than the color of your code, so it'll be really obvious to you what's a comment and what's not. So you don't have to stress about it too much, but sometimes you'll say, oh, why is all my code green? You know, all of a sudden it's because you probably put this in, but you didn't put this in. You know what I'm saying? So,
Is green the regular?
yeah, green tends to be the comment color, or sometimes it's like a light gray, but you'll see how it works in Eclipse on Wednesday. But that's the idea. Comments are just really helpful notes to yourself. You got it? All right. So, back to methods. So we've seen methods. We've seen that you can create your own methods and do something really helpful for yourself. Now, there's one method in Java that kind of stands out above all the other ones that's really important. And it's not a method that you write on your own. It's called the main method. And it looks exactly like this. Now, what the main method is remember before we were talking about how a program is just a list of instructions? Well, the main method is where that list starts. This is where Java goes to start off your program. And it has this exact signature. It's got to be public, static, void, main, this stuff. This is really confusing at first. And a lot of people knock Java for making their main method so complex and confusing. And I knock them too. But it's just the way it is. And again, you don't have to worry about it too much because Eclipse, what we're going to be using to write our programs in, does this for you. It creates this, and then this is where you start up your Java program. So you'll see in the next slide how it looks, which is this. So this is our first complete Java program that we're going to be able to understand. Okay? So this part here, public class, main class, we're actually going to go over next time, so I kind of lied. We're not going to completely understand it, but this you don't have to worry about right now. And this is like the completing curly brace of that. So just look at this in here. So this is our Java program. This is our list of instructions. Where are we going to start here? Where is the first line that's going to be executed? Does anyone have a guess? Well, you might think it's going to be here, right? Because it's the top of the function, or it's the top of the program. But it's actually here, right? Because this is our main method. Remember this slide right here? Oh. This right here is the same as this right here. So this is our main method. This is where we're going to start off. So let's go through this line by line just so we can understand what's going on, right? This is our first line. Can anyone see what's going on there? It's a little tough because there's some syntax there that we haven't gone over yet. But what this is doing is declaring a new variable right here, right? A new variable named answer, in variable type double. Right? Not too hard. Now we're defining it right here on this half. Now how are we defining it? Double, answer, so the new variable of type double, name answer, gets the return value of this function with these inputs, right? This is called calling a method. This is calling a method or invoking a method. So now what happens is Java's going to say, okay, I need to figure out what the answer of this is going to be. I need to figure out what the return value is going to be, so I'm going to go up here. Oh, here it is. Here's the method. Here's the method that you already defined. Average, right? And I'm going to use 2.5 as num1, and I'm going to use 7.5 as num2, right? Because these are the inputs that you defined. Yep, Dan.
So you don't feel like do 2.5 plus 1.1?
No, because that's how this works up here. Is that these are your parameters. This is your input. So because you've already declared it up here, it's fine. You don't have to have the variable that goes in here be named num1. It can just be any double, right? As long as it's a double. This is a double and this is a double. So it's the first double, comma, second double. Those are your inputs. And then it goes up here, and now it starts this function off. So what's going on in this line? Can't even see? So what's going on here is that a new variable of type double, named sum, gets num1 plus num2. Well, what are num1 and num2? 2.5 and 7.5, right? You can kind of see how that works? Well, so what's sum then? 10. Nice, okay. So we just basically declared a new variable, double of type double, named sum, which gets the sum of num1 and num2, which we know is 2.5 plus 7.5, which is, of course, 10. Okay, nice. End of line. Now it goes down to the next line. So what are we doing here? Yeah, so we're declaring a new variable, right, with the name, average, of type double, and it gets, what does it get? Sum divided by 2, right? So what's that going to be? 5. Okay, so there we go. We've got a new variable, name average, type double, gets 10 divided by 2, basically. It's equal to 5, and now we go down here to the next line, return average. So this is the kind of the weird part before that kind of probably confused you a bit. Well, what return average means is that when this is done, the return value is going to take its place. So now we've got the return value here, which is 5, right? So this double, name answer, gets the return value of this function, which is 5, right? Can you guys kind of see that? And then we go down to the next line, and it does this thing, system.out.println answer, which we'll describe in a few slides here, but that is basically to display the answer to the user, and then we return out of this, and our Java program's done, right? A little confusing, but you can kind of see where it's coming from, right? You can start to see how it's working. We defined a method, we called the method here, and we used the answer of the method to display it, and then that was the whole program. Not rocket science, not groundbreaking, definitely confusing at first, but you got to start somewhere, right? So, basically, as you program things and as you start to do this stuff, you're going to make mistakes. It's complicated, right? There's a lot of stuff here. But basically what you have to do is what we just did. When you see something's not working, you're getting an error, or it's not working the way you want to, you've got to just go through, just like we just did, line by line, okay? We went to the first line, we said, okay, that's what's going to happen. We went down to the second line, we said, okay, that's going to call this method. Okay, we're going to go up here to this method and see what happens there. Then we're going to see what it returns. Then we're going to go through the whole thing. So you go through it line by line. You see what the computer's going to do it in your head, and then usually then the errors and your mistakes will become clear because you say, oh yeah, okay, this isn't a divide, this is a times, or this should be, a plus instead of a minus, or this is not the right variable that I was using here, it's got to be a different one. So that's how you can kind of power through it and say, okay, I've got these errors, but I'm going to figure it out, and I'm going to just go here line by line and figure it out for myself. So that's kind of what's going to happen because you're going to get bugs, you're going to have mistakes. It's just how programming works. And that's why it can be really discouraging for people at first. Because you spend all this time writing and you say, oh yeah, this is perfect, this is going to work perfectly. And then you run it and it's just a bunch of errors. And you're like, I thought I was doing it. I thought I had the right thing. I thought I had it all figured out. And maybe you did, but maybe you had a typo, or maybe you just had one line wrong or something. So you can't get discouraged. You just have to power through it, and you have to use this hand simulation if you get stuck. Now, when you get a little bit more advanced, there's some tools you can use to help you, but at first, this is the best way to do it. Okay, so we had that weird thing that I said, just to display something to the user, right, or display something to you as the programmer. This system.out.println with a parameter here. And so this is basically called a print line, okay? And this is probably going to be the line of Java you write the most in your Java career. And you probably are thinking, why is that even useful? And well, it's useful to yourself because you're able to display the values of variables to yourself while you're programming really quickly and really easily. And that actually ends up being a really helpful thing. Not that you could really know yet exactly why, but you will. So this is basically the easiest way to display something to yourself without having to make a big graphical interface or whatever to get the job done. But this is a really helpful thing that you'll see on Wednesday, 2 days from now. So basically, back here, this Wednesday at 7, we're going to have our first lab, and it's going to go over all the stuff we just talked about, which I'm sure you're really confused about. And after Wednesday, you're going to have a much, much stronger feeling of understanding. So basically, it's right back here in this room. Bring your laptop, bring a charger if your laptop doesn't usually last an hour and a half, which kind of surprised mine is right now. And yeah, it's going to be fun. You guys are going to be writing some programs. You're going to be getting going. It's going to feel really nice. And this lesson will be on the site tonight or tomorrow morning. So if you're motivated enough, maybe review it Wednesday afternoon right before you come here. Give it 10 minutes. Just look over the slides real quick. And that's the first lesson. Really good job, guys. And yeah, you might be confused now, but it's going to become clear as we go. And don't get stressed. It's going to be good. All right. Take a bunch of Starburst and stuff. And thanks a lot for coming out.
Do we need our laptops on Monday?
Yeah, Monday you don't need them unless you want to take notes or whatever. But it's you can just leave them at home if you don't want to.
Have you ever written a TI program?
TI?
Yeah, the calculators.
Oh no, I haven't actually. Yeah.
It's my teacher did try to teach us for a day.
Yeah.
It was pretty cool. You could write math.
Yeah. My mom actually writes those every now and again. She's a math tutor.
Yeah.
And so she kind of uses those to help her students out and stuff. But I actually never have. I think it's actually going to be a lot simpler than what we're going to be doing. So I'm sure you'll be able to get that done after.
I wasn't that great. I didn't really listen.
Yeah. Okay. Yeah, take a bunch of those Starbursts. I'm kind of hacking the screen recording that I did because it didn't come out exactly the way I wanted.